Hola amigos, so now let's move on to our next topic, that is 7.4 absolute angle of attack. And we are following the book Introduction to Flight by J.D. Anderson. And here you can see the positive cambered airfoils, oriented in two different angle of attacks. So we are learning about angle of attack, basically absolute angle of attack over here, because in stability and control analysis we are more interested in absolute angle of attack than the angle of attack, or generally known as geometric angle of attack of the airfoil. So we are more interested in the absolute angle of attack rather than geometric angle of attack of the airfoil. So what happens when the angle of attack changes because of the disturbance or the gust on the airfoil? It will change a little bit amount of lift, and that little bit amount of lift will create a movement that will disturb the airplane stability, which we do not want. Okay, so that is why we need to analyze this absolute angle of attack, or we need to know about this absolute angle of attack that tells us the orientation of the wing. Okay, so here if you see, you have the airfoil in the A part, the above part. If you see, it is a positive cambered airfoil. Both are same airfoil, A and B part, and they are just oriented at different angles. Okay, so in the first part you can see the chord line is below the horizontal line, or below the free stream velocity V infinity. In symmetric airfoil, if V infinity is aligned along the chord line, then there will be no lift. But in a positive cambered airfoil, if V infinity gets aligned with the chord line, then there will be some lift. Okay, in a positive cambered airfoil, if V infinity aligns with the chord line, there will be some positive lift. Okay, but here you are seeing the chord line is below, so the lift force over here is reduced as the chord line goes down the horizontal line. And when this angle alpha L equals 0 is achieved, then the pressure distribution around the airfoil is such that the pressure below and above is same, and there is no net force vertically upwards or perpendicular to the V infinity, which means there is no lift at this orientation of the airfoil. And when you draw a line from trailing edge in the direction of free stream, that is from trailing edge to the V infinity, you draw a line. That line will tell you the zero lift line of the airfoil. Okay, so as the name suggests, at this orientation the line is known as zero lift line, because at this orientation, in the A part we are talking about, okay, we haven't gone to B part till now, only the A part we are discussing. So at this orientation the lift force is zero, and the zero lift line is the reference that tells us that at this orientation lift will always be zero. So if the chord line is below at an angle alpha at lift equals to 0, alpha L equal to 0 means alpha at lift equals to 0, then the orientation at which the airfoil is inclined, at this orientation there will be no lift. So now you have understood that at in A part there will be no lift at that orientation for a positive cambered airfoil. So for the same airfoil below, which is now inclined at angle of attack alpha, this angle of attack alpha is the geometric angle of attack, and this alpha A is the absolute angle of attack, which we are discussing over here. So what is happening over here in the B section is that in the first part, airfoil is oriented in such a way that there is no lift, and now the orientation is increased at a geometric angle of attack alpha, which will create some lift. And from the definition of absolute angle of attack, you can see it is the sum of geometric angle of attack alpha plus alpha at lift equals to 0. Okay, so alpha absolute is the sum of geometric angle of attack and alpha at lift equals to 0, and at this orientation the same airfoil will produce the lift. Okay, so if you observe the absolute angle of attack, or see the angle of attack from the CL alpha curve, we know for a positive cambered airfoil from aerodynamics will give us the curve as shown on the left side. Okay, so because at lift equals to 0 there will be some negative angle of attack. Okay, so the value of alpha at lift equals to 0 is negative. Sorry, just a second. Yeah. So as you can see, alpha at lift equals to 0 is at left side from the origin, which will tell us that alpha at lift equals to 0 is a negative value. Hence the airfoil is oriented in the downward direction. So for a cambered airfoil, you can see the CL alpha curve, it's a straight line up to an angle alpha stall, at which the lift reduces drastically, after which the lift reduces drastically. Okay, so for absolute angle of attack, the angle is absolute angle of attack is alpha geometric plus alpha at lift equals to 0. And if we apply that concept, alpha absolute angle of attack, for CL alpha curve of the airfoil, we have this B curve which is shifted towards the right. The slope remains the same. Okay, the slope remains the same, only it shifts towards the right. For different cambered airfoils, the slopes will be different, and the zero lift angle of attack will be different. Okay, so here for this given positive cambered airfoil, the graph is shifted towards right, keeping the slope of the graph same. So absolute angle of attack is here the sum of angle of attack, geometric angle of attack, which is alpha plus alpha at lift equals to 0. And as I said, in stability and control analysis we use absolute angle of attack, and we don't use generally geometric angle of attack. Okay, it is common practice to use absolute angle of attack in stability and control analysis. Okay, thank you.